If you've ever had an MRI, you totally know the drill. You lie perfectly still inside this giant, incredibly loud tube. But what happens if you twitch or, just breathe a little too deeply? You get a blurry image. And it's a huge, huge problem in medicine. But there's a new hero emerging from the world of computer science to fix it. So today, we're going to dive into how AI is stepping in to bring these critical images back in the focus. No, seriously, think about it for a second. It's almost impossible, right? A tiny little cough, a muscle spasm you can't even control, that is all it takes. And in the high-stakes world of medical imaging, that one tiny little movement can have absolutely massive consequences. Okay, so let's introduce the villain of our story today, motion. You see, during an MRI scan, any movement from the patient, no matter how small, can basically corrupt the data. It can turn a potentially life-saving image into, well, a completely useless blur. And wow, the difference is really night and day. Over on the left, you've got a sharp, clear diagnostic quality image. Every detail is crisp. But on the right, yeah, that's a mess. Those smudges and ghost-like distortions are what doctors call motion artifacts, and they can easily hide the exact thing a doctor is trying to find. And look, the stakes here are just incredibly high. A blurry scan could lead to a misdiagnosis or even a wrong one. The best case scenario is that you have to do an expensive, time-consuming rescan. And what does that mean? It means more waiting and way more anxiety for the patient. It's just a deeply frustrating problem for literally everyone involved. But what if you could just fix the blurry picture? That's where our hero finally enters the scene. We're talking about a very specific kind of artificial intelligence that's basically being trained to act like a master art restorer, but for these supercritical medical images. So the tech that makes this possible is what we call a generative AI model. And the best way to get how it works is to imagine an expert art restorer, someone who spent their entire life studying thousands of pristine masterpieces, but also thousands of faded, damaged canvases. Over time, they develop this incredible intuition for how a painting should look. Well, this AI does the exact same thing, but its library is made of thousands and thousands of MRI scans. So how does it actually learn? It's really a three-step process. First, you give the AI a massive library of before and after shots, a perfect, crystal clear scan paired right next to its blurry, motion-corrupted twin. Second, during its training, it meticulously learns the exact digital patterns that cause that blur. It's basically learning the physics of the mistake. And finally, it uses all that knowledge to reverse the process on a brand new, blurry image it's never seen before, restoring it to what it predicts the clear version should look like. Now, this all sounds pretty amazing, doesn't it? A kind of digital magic eraser for blurry MRIs. And a big systematic review of all the current research confirms it. This stuff shows incredible promise. But, and this is a big but, like any young hero, this AI, well, it's not perfect yet. It has its own challenges it needs to overcome. And this gets us to the central tension of the research right now. It's kind of a double-edged sword. On one hand, these AI models are fantastic at zapping those obvious motion blurs and improving the overall image quality. But on the other hand, the very act of fixing the image can sometimes introduce tiny new errors, really subtle distortions that weren't even there to begin with. So it's absolutely crucial that we understand these specific hurdles. The scientific community is really zeroed in on a few key weaknesses that we have to address before this technology can be rolled out widely and, most importantly, safely in hospitals. Okay, here are the big three challenges. First, there's what's called limited generalizability. An AI trained on images from a scanner at one hospital might not work so well on images from a different brand of scanner at another hospital. Second, there's the reliance on all that paired data, those perfect and blurry pairs. They're really difficult and expensive to create in large numbers. And finally, and this is the big one, the risk of visual distortions. In its effort to fix a blur, the AI might accidentally erase a tiny but vital detail. Or, even worse, it might hallucinate a detail that isn't actually there at all. But hey, scientists aren't just here to point out problems, they're here to solve them. The research also lays out a really clear training plan, a roadmap, if you will, to help our AI hero become more reliable, more robust, and ready for prime time. So here's the game plan. First, researchers from all over need to work together to create these huge public data sets. This lets different AI models get trained and tested on the exact same standardized info. Second, the whole field needs a universal grading system, a way to measure both how blurry an image is and how well the AI actually performed. And third, the long-term goal is to design smarter, more advanced AI that can learn with less data, so it isn't so dependent on those perfect pairs. And it's so important we don't lose sight of the why behind all this tech talk. Fixing these technical challenges isn't just some academic exercise. The end goal, the whole point, is to improve diagnostic accuracy, to cut down on the billions of dollars wasted on rescans, and, most importantly, to improve the care and the outcomes for every single patient. Which kind of leaves us with this one final, really fascinating question to chew on. This technology is all about correcting what we see, about cleaning up a messy reality to show us a clearer version of the truth. But as these incredibly powerful tools get better and better at editing our vision, the real challenge for us becomes, how do we learn when and how much to trust what they're showing us?